an exponent here and an exponent here, an addition here, and notice this exponent is over a set of parentheses, and the parentheses group this subtraction. So, parentheses first, 3 minus 4 or 3 plus negative 4 is going to give us a negative 1. So we have the opposite of negative 1 to the third power. So after parentheses we go to exponents. So the negative 1 to the third power is going to be negative 1 times negative 1 times negative 1, which leaves us with negative 1. So we have the opposite of negative 1 to the third power, which gives us the opposite of negative 1. Now notice this exponent is over the fraction. The fraction is actually reducible to 2. So this is actually 2 squared. So when we do this exponent, we get 4. So then we're left with the opposite of negative 1 plus 4. Well, the opposite of negative 1 is a positive 1. 1 plus 4 gives us 5. Okay, so when we're evaluating expressions and we are given specific numbers for the variables, so here it wants us to evaluate this algebraic expression, and it gives us numbers to replace for the variables. So this expression up here doesn't have any variables, so we just go ahead and perform our operations. This one says to evaluate this expression when a is 6 and y is negative 2. So we're going to replace the a with 6 and the y with negative 2. Now, a good thing to do just to keep your signs organized is to first replace your variables with parentheses. This way, if one of your variables is negative, you don't lose that negative sign when you replace the variable. So a is 6 and y is negative 2. So we have 6 minus 2 times y, which y is negative 2. 6 and minus is plus negative. So we have 6 plus a negative 2 times a negative 2. Multiplication comes before addition. Negative 2 times negative 2 is a positive 4. 6 plus 4 is 10. Now this expression, we're going to replace all of our a's with 14 and our c's with 4s. And again, it might help you when you're first starting out, replace all your variables with parentheses. So then these first two parentheses were a's, so we're going to drop the 14 in there. The second two parentheses were c's, so we're going to drop 4s in there. So then using our order of operations again, if you want to start on top or bottom, that's up to you. I tend to always start on top. So on top, I have an addition and an exponent. I do the exponent first. 4 squared is 16. So I have 14 plus 16 on top. Then I go ahead and complete the addition to get 30 on the top. On the bottom, I have a multiplication here. 3c means 3 times c. And then the subtraction or addition of the opposite. So I'm going to do the multiplication first. So the opposite of 3 times 4 gives me the opposite of 12. So then I have 14 plus the opposite of 12, which gives me 2. Then the 30 over 2 reduces to 15. Remember, final answer of fraction, make sure it's in simplest terms. Reduce it if possible. And you would not want to write this as 15 over 1. I mean, technically it is the same thing, but it's not in simplest form. 15 over 1 is just 15. Okay, so if we remember previously, a variable is a symbol or letter used to represent a value that is subject to change. Like before, this expression, this says to evaluate it when a is 14 and c is 4, but we could have said, or it could have told us a was something else and c was something else. So your variables are subject to change. Your variables represent unknown numbers. Now, a constant is a value that is not subject to change. We saw that before when we talked about fixed cost would be, like your rent. Your rent's the same. Out of whatever you spend every month, your rent is always the same. Now, a term is a constant or a product or quotient of constants and variables. So when writing products of numbers and variables, we exclude the operation. So 2xz means 2 times x times z, but we don't write the multiplication. We just know when they're sitting next to each other, this means multiplication. So this is an example of a term, 2xz. This is a product of a number or a constant and a couple of variables. An algebraic expression is a sum of variables and constants. Oops, sorry. Basically, an algebraic expression is a sum of terms. Terms can easily be seen because they're separated by pluses and minuses. Keep in mind, minuses are plus negatives. So this 7xy squared plus 2x minus 400, or if you want to rewrite the minus 400 as plus and negative 400. This is an algebraic expression with 3 terms. 7xy squared is a term. Then we have a plus sign. 2x is a term. Then we have actually a minus sign, which is plus negative. So the third term here is a negative 400. So the first term is a constant and a couple of variables. The second term is a constant and a single variable. And the third term is a constant. This gives us an algebraic expression. It is a sum of 3 different terms. Now these terms, factors, we can think of as numbers and variables that are multiplied to create terms. So looking at the term 7xy squared, it's made up of the factor 7, x, and 2 factors of y. Remember, y squared means y times y. So we actually have 4 factors making up this term. Technically we have 5 because the number 1 is a factor of everything. The constant factor 7, in a term, the constant or the number is called the coefficient of the term. Okay, so here 7 is my coefficient of the first term, 2 is the coefficient of the second term. The third term is a constant, so you would not consider that a coefficient. If it's a term that has variables, the number or that is part of that term is your coefficient. And just as a side note, if a term is just a single variable, the coefficient of that variable is 1. So every term has, or every variable term has a coefficient. If there's no number in that term, the coefficient is 1. Okay, so as we said, variables represent numbers. We can perform the same operations on variables that we can on numbers. Just the variables are unknown numbers, so we have to keep that in mind. So if we look at this expression, 2c plus 6c, we don't know what c is, but c is the same in each of these terms. So if we have 2 of these c's and then we add 6 more of these c's, together we have 8 c's. Right? If c happens to be the number 2, it's the number 2 in both of these terms. So if you have 2 of a variable and 6 of that same variable, you have 8 altogether. So you can think of it as adding the coefficients of that variable. 2 plus 6 is 8, so we have 8c's. And here we have negative 8c plus a negative 4c, which would give us a negative 12c. Now, because these two terms have the same variable, same exponent on that variable, right? There's no exponent on either of these c's, so it's known that the exponent is 1. If a number or a variable does not have an exponent, that exponent is actually 1, we just don't write it. So because it has the same variable and exponent, these are called like terms. So like terms have the same variable and exponent. So 2x and 4x are like terms, but 2x squared and 4x are not like terms, because this is an x squared and this is just an x to the first power. So whenever you're looking at your terms, you have to look at the variable sets and make sure it's the same exact variables with the same exact exponents. 4x squared y to the third z and 8x squared y squared z are not like terms. They're close, but they're not like terms because this term has 3 factors of y. This term only has 2 factors of y. So like terms have the same exact variable and exponent combinations. And we are able to combine like terms. So in this expression, negative 7x squared plus 9 plus 13x squared minus 5x. We have 4 different terms. 2 of them are like terms. So we can combine. We can take the negative 7x squared, add it to the positive 13x squared to get a 6x squared. The 9 and negative 5x we can't do anything with, so those remain the same because those are not like terms. We can't combine them with anything else. So this 4-term expression simplifies to a 3-term expression, and you can't go any further than that. So adding and subtracting terms, you can only add or subtract like terms. Multiplying is a little bit different. We can multiply any terms. When we multiply a constant and a variable term, you multiply the constant by the coefficient of the variable term. Again, keep in mind, if the variable does not have a coefficient, it's actually a 1. So 3 times 4a is 12a, because 3 times 4 is 12. Remember, multiplication is repeated addition. So 3 times 4a means I want 4a plus 4a plus 4a. 4 plus 4 plus 4 is 12a. So when you're multiplying a constant times a variable term, you just multiply the coefficients. And keep in mind, if we have 3 times z, this is actually 3 times 1z. 3 times 1 is 3, so we end up with 3z. Distribution is the act of multiplying a number over an entire expression. It's signified by placing the expression in parentheses, and the number to distribute will be written either in the front or the back of the parentheses. But be careful, when you distribute, it's only over the expression inside the parentheses. So in this expression, 10 times the quantity u plus 6. We're going to distribute the 10 over both of these terms. So we have to distribute 10 times u. So distribution is multiplication. We multiply the 10 by every term inside the parentheses. 10 times u, or 1u, is 10u. 10 times 6 is 60, so we end up with 10u plus 60. Now here notice there's a negative in front of the parentheses. This means I want the opposite of this entire expression. Taking the opposite of an entire expression is changing the sign of every term of that expression. So you can kind of think of it as distributing a -1 over each of these three terms. So if you want to rewrite it as a -1, that's fine. -1 times -4 gives me a positive 4x. -1 times -4y gives me a positive 4y. -1 times a positive 4 gives me a -4. So we're taking -1 times the -4x plus -1 times -4y plus -1 times 4. Right? We keep these different operations between our terms. And then in ALEKS, it does not let you type plus negative, so your final answer you would have to change back to a minus. So, like I said before, you only distribute over what's inside the parentheses. So this 2 is going to be distributed over the u and 5, but not out here. You stop at this parenthesis. So 2 times u is 2u plus, over here, plus 2 times 5 is 10, and then I stop distributing and I keep the minus 4u, which you know is plus -4u. So then I have 2u and a plus -4u, which gives me a -2u. Oops, and that has to be changed. Oops, sorry. But yes, in your slides you'll see that this will change to a, oh, no, I did it right over here. Sorry. Yeah. 2 and -4u is -2u. Okay, here. Never mind. Plus 10. So this is your final answer. -2u plus 10. Okay, so it looks intimidating, but take it one operation at a time. Parentheses first. We can't do anything inside those parentheses. So we go to our next operation, which is multiplication, right? We have a minus here and a minus here. But this 6 over parentheses is multiplication. So we do that multiplication first. So if you want to rewrite your minuses as plus negatives, we have -4y plus -6 over the -2z plus 3y plus -2z. So we distribute the -6 times the -2z and the -6 times the 3y, illustrated right here. -6 times -2z is a positive 12z. -6 times 3y is a -18y. So we have -4y plus 12z plus -18y plus -2z. Combining our like terms, a positive 12z and a -2z, and then a -4y and a -18y. So -4y and -18y gives me a -22y. Plus 12z and -2z give me a positive 10z. So our simplified form is -22y plus 10z. And that is the conclusion of the Week 4 Part 2 lecture.